The second method of factoring is that of grouping. In problem number 6 here, it's already partially grouped. We notice that there's an x minus 5 in the first half of the problem and in the second half of the problem. And it's that x minus 5 that's going to get factored out of each half of the problem and brought out front. When you divide x minus 5 out of the front half of the problem, you get x squared left over in the first half of the problem and 7 left over in the second half of the problem. Now, sometimes we just don't see how this worked. So let me show you this written in a different way. If I had x squared times blob plus 7 times blob, then it's easier to see the blob in each of the two terms, and we can factor that blob out and have left over x squared plus 7. Now, just rearrange this in your head and notice that the x minus 5 is the blob, and it's that x minus 5 that's written out front. Notice it's just written out once. It's not x minus 5 squared out front, just x minus 5. Over here, we only have a single blob out front, and we can check that blob times x squared and blob times 7 creates the line above. So this is how we handle the grouping method. Now, when I factored out this x minus 5, I brought it out to the left. It's perfectly fine to write the x minus 5 off to the right. It's the commutative property of multiplication that says a times b is the same as b times a. So as long as what's inside the parentheses is correct, it's okay if you reverse the two parentheses with respect to each other. In this next problem, we see an x cubed plus 2 in each half of the problem, and we're going to factor that out front or off to the right. I choose out front. X cubed plus 2 divides out, and in the first half of the problem you have 5x left over, and in the second half of the problem you have minus 8 left over. And so that would be completely factored. Now, moving on to number 8. It looks different. We see 4 terms listed here, and usually when we see 4 terms, that's a clue that the factoring method by grouping works. I'm going to split this problem right down the middle, and note that in the first 2 terms there's a 3 in common. I'm going to factor that 3 out, leaving q plus p. And now to the second half of the problem, I notice there's an r in both terms. I'm going to divide the r out, leaving q plus p. And then I have what we had in the line above, problems above. Q plus p is common to each half of the problem and can then be factored out in front. Not plus, this should be times 3 plus r. So this problem added an extra step beyond the 2 problems above it, where you had to figure out how to split it up first. Looking at problem number 9, we see that it goes from w to the 5th down to w to the squared, and then w to the 3rd is after that. It's not following the descending order of exponents. And I'm going to choose to rearrange the second and third terms here, rewriting this as 8w to the 5th minus 10w to the 3rd plus 12w squared minus 15. Then I'm going to ask, is there a GCF that goes into all 4 terms? Notice how 8, 10, and 12 are all even and can be divided by 2, but the 15 is not divisible by 2. And the first 3 terms also have w's, but the last term does not contain a w, so nothing can be factored out. But I still want to ask, can I take out a GCF? Because that's the most important type of factoring that's commonly overlooked. Splitting this problem down the middle, out of the first 2 terms I can divide out a 2w to the 3rd, leaving 4w squared minus 5. Out of the second half of the problem, the 12 and the 15, they are each divisible by 3. Dividing out by 3, I have 3 times 4w squared minus 5. And looky here, we see that 4w squared minus 5 common to both halves of the problem. If you don't see that common to both halves of the problem, double check your math, because usually this is set up so that this will factor nicely. So 4w squared minus 5 can be divided out at each half of the problem. In the first half of the problem, we're left with 2w to the third. And in the second half of the problem, we see a positive 3 remaining. So we have our factor times factor making the product as the answer to this problem.